Okay, we're introducing area of a rectangle model with third grade. Okay, so we have the kids get out the brown rod, and how long is that brown rod? And let's with our finger, find a vertex. And we've already had a conversation about about the different dimensions, and we know what a vertex is. And so with your finger, find how long, find the edge that makes that brown rod different from all of the other all the other rods, all the other colors. It's that length right there. Okay, so we're going to put that down. And can you have students find all the ways to make that length using only one color, using other rods? So what they should do is they'll see that they can use it making red rods like this, and that they can make it using purple rods like this, and they can use it with white rods like this, and then stop and have a minute to talk about how this is repeated addition. Okay, can we read this as repeated addition? Sure. So let's see. Let's look at just the red row right now. And so this is 2 plus 2 plus 2 plus 2, which is 2 added 4 times. Or we could look at it as 4 groups of 2, which is 4 times 2. And then you could do the same thing with the purple. So this is 2 groups of 4, or 4 plus 4, and which is also 8. And this is, now we've got 8 groups of 1. 1 plus 1 plus 1 plus 1 plus 1, blah, 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 repeated addition, right? Okay, so now we put these aside and put only the brown rod down in front of us, and take a minute. Take our hand, and with our hand, so our students already know what a vertex is, and they already know what a edge is. So with your finger, find a vertex. Find the 2 edges that share the top face. So find them with your finger, then cover that top face with your hand. We're using our whole hand to cover that top face. We're covering, what part are we covering? The face. How do we measure? What is the face? It's an area. And how do we measure that? We're going to measure that and have the kids use their resources, right? How do we measure that? We measure that in square units. Okay, so let's measure this in square units. So now the students cover it, right? Cover it up. And they will see that it has an area. So we want to get at, that brown rod has an area of 8 square units, right? Well, what do they think the dimensions of this face are? We're only talking about this top face, this part right here. So let's go back to our vertex and feel those 2 dimensions, right? How can we measure how long the longer dimension is, right? We can line these up next to it to measure how. And we're gonna need to introduce vertical and horizontal. So this is horizontal, and we're measuring the horizontal dimension. And for that, I usually have kids lie down on the floor. That's horizontal, and stand up for vertical, just so they have that. And do that a couple times. Go horizontal, go vertical, go horizontal, go vertical. So then let's measure the vertical, and that's 1. So then we can write. Okay, so let's draw that rectangle. So here's our vertex. Here's our dimension of 1. Here's our dimension of 8. Let's draw that rectangle. Let's label the dimensions. And then let's say we're going to label that area is 8. So that doesn't look very good, but anyways, so now we go back and we pull out, so keep that there, right? Now let's go back and we pull out the purple row that we made, right? That purple rectangle. Does it have the same area And you can cover the purple with the brown or the brown with the purple, right? Does it have the same area? Yes. How do you know? Because it covers the same amount with no gaps and no overlaps, right? And so, and how else could we tell? We could stack these guys back up on it if we wanted to, right? So this rectangle, it's different color, it's two pieces joined together, but it's got the same dimensions, 1 by 8, and it's got the same area. So here's the question. Is it possible to make a different rectangle that still has the same area, but that has different dimensions? And so get them to sort of, and let them think about it a little bit, but get them to sort of see, can you rearrange them so that it's still a rectangle and it still could be covered by 8, but that the dimensions are different? And so somebody in the room will do this, and you let them puzzle through it a little bit. But so have them do this and then have them prove that it has an area of 8. And once you've got it in the room, right, you can draw it. So it's 2 by 4. And so is it 2 groups of 4? Right? So you already have used this before, right? So we can also call it, so it has an area of 8, which is 2 times 4. So it's 2 by 4, and it's 2 groups of 4, and that has an area of 8. Okay? And then you can have them do that with, this way too. What about this? Does that have still have the same area? And then from there, go to something like 12. Let's do the same thing with 12. What's the area of this rectangle, this top? Because once you've done it with one, then you can say this, I know these are 2 rectangles put together, but we're going to pretend that it's all one and that's all one color. And then how many rectangles would it take? I'm sorry, how many squares would it take to cover this? Can we make this using all of one color? So you can have them do this first, just so they have them available, and they've kind of started thinking about it a little bit. And then you can have them say, is it possible, bring down one of them. Is it possible to rearrange this so that still has an area of 12, but so that instead of being a 1, having a vertical length of 1 and a horizontal length of 12, that it's different. The dimensions are different. And so they'll do things like this. And then you can sort of say, how many different rectangles can you make that have an area of 12? And what are their dimensions? And then have them record them.
And do with each different...
Yeah, you could do it with each one. I mean, you don't have to, everyone doesn't have to see all of them. You're just trying to get the idea of the area of a rectangle, that they're getting them to see how the equal groups relate to the area of a rectangle, and just seeing how for the same area, this is conservation of area, that for the same area, you can have different dimensions. So that's where I would go with it. And then what you could do, you don't have to have everybody do the same numbers. You could do something like this, where you have like some choice, right? So you can you can give them options. So option 1, option 2, option 3. And you could have, so have them do, so you're all going to do 8, right? You'll all do 12, and then you could pick, you could all do 8, you all do 12, and then you could have 16 here. For kids who need a little more, you could have them do like 24, you know what I mean? Have a couple other ones, and then maybe have something like a larger number, like maybe, well, you could do 48 or 56 or something, something else, but like, so say 48 or something like that, right? And just go through this. How many rectangles can you make? What's your prediction? And so this would be another day. I
Okay.
think that's good.